Hi there. Welcome to our video on smart offices. I'm Fahmi, and today we're diving into how modern technology is transforming the way we work. Explanation function of smart office. Next, explanation of component. RFID reader, RFID card. RFID used in real-life student or staff ID cards at school, library cards, touch and go or smart tag cards for tolls, gym or office entry cards, tracking items in a factory or warehouse. Next component is ESP32. The ESP32 is a low-cost, low-power, system-on-chip SoC microcontroller with integrated Wi-Fi and Bluetooth, developed by Espressif Systems. It's widely used in IoT, Internet of Things applications due to its versatility and connectivity features. ESP32 and RFID scanner communicate. Think of the RFID scanner as the mouth and the ESP32 as the ears and brain. The scanner speaks the ID number from the card, and the ESP32 listens and decides what to do. How it works step by step. ESP32 Plus RC522 module. 1. You place the RFID card near the scanner. 2. The RC522 reads the card's ID, example 0A3B5C14F. 3. The scanner sends that ID to the ESP32 using SPI wires. 4. The ESP32 checks, is this ID allowed? 5. If yes, it unlocks a door or turns on a green LED. If no, it shows a red LED or keeps the door locked. Next, breadboard. A breadboard is a tool used to build electronic circuits without the need for soldering. It allows you to connect components like microcontrollers, LEDs, resistors, and more easily, and you can change or modify the connections whenever you want. This is how breadboard works. 1. Power connections. You can connect VCC like 5 volts or 3.3 volts to the power rail and GND ground to the negative rail to power your circuit. 2. Connecting components. Components like LEDs, resistors, transistors, or a microcontroller are placed into different columns. If you insert the legs of components into holes in the same column, they will be connected electrically. 3. Wires. You can also use wires to make connections between components in the circuit. Next components are jumper wires. Jumper wires are used to make quick and temporary electrical connections between components in a circuit, especially during prototyping or testing. Here are the main uses. 1. Prototyping on breadboards. Jumper wires connect components without soldering, making it easy to build and modify circuits. 2. Testing circuits. Engineers and technicians use them to test connectivity or temporarily bypass parts of a circuit. 3-point interfacing modules. They connect microcontrollers, like Arduino or Raspberry Pi, to sensors, displays, motors, etc. 4. Educational purposes. In electronics training or labs, jumper wires help students experiment and learn without permanent setups. Next, how to connect the jumper wires. 1. Identify the wire type male-to-male used between breadboards or breadboard to male header pins. Male to female, used from male pins, e.g. on an Arduino, to female header pins, e.g. on a sensor. Female to female, used between 2 male header pins. 2. Use a breadboard, if applicable. Insert one end of the jumper wire into a hole on the breadboard that connects to your component. Insert the other end into another breadboard row or into a microcontroller pin, connecting to a microcontroller like Arduino. Match the jumper wire to the correct pin. For example, connect a sensor's VCC to 5 volts, GND to GND, and signal to a digital input pin. Ensure the wire is fully inserted to make a good contact. 4. Observe polarity and function. Red for power, VCC, black for ground, GND, and other colors for signals. This is a common color code, though not mandatory. Double-check your circuit diagram or data sheet to avoid reverse polarity. 5. Check the connection. Tug gently to ensure wires are snug. Power the circuit and test with a multimeter or code if using a microcontroller.